This video is going to focus in on ions. So if you go back to the chapter on how the atom is structured, I had told you that the number of protons equals the number of electrons. Okay. The problem is that in actuality most atoms don't exist like this. Most atoms exist in such a way that the number of protons does not equal the number of electrons. And when the number of protons doesn't equal the number of electrons, you form something called an ion. And an ion is a chemical species whose number of protons does not equal the number of electrons. So there are two types of ions. Okay. The first type of ion is called a cation. Okay. Most people would call it a cation, and if I heard you say cation, I'd ask you if they were salted or unsalted. All right. Terrible joke, but just something you have to deal with in chemistry. A cation is a positively charged ion. And the reason why it's positively charged is because this is going to have more protons than electrons. So the number of protons is greater than the number of electrons. The other type of ion is called an anion. I won't do an onion joke. Onion. Anyway, an anion is a negatively charged ion. And in this case, the number of electrons is greater than the number of protons. So one of the features that you'll notice with most ions is that the valence shell of an ion is usually either full or empty. So we're usually talking about either having 8 electrons or 0. Okay. It's a little bit more complicated than that, but I think just to keep things simple, this is as simple of an explanation as I could come up with. So we're just going to stick with it. So I want to start off by talking about the simplest, or one of the simplest atoms, lithium. Okay. And if I asked you to draw the electron arrangement around a lithium atom, okay, that doesn't have a charge, or is uncharged, you first have to ask yourself, how many protons do I have? And you would say 3 protons. And in uncharged lithium, where the number of protons equals the number of electrons, that number is going to be 3 electrons. Okay, so you'd have your lithium in the middle. You'd have your first shell with your 2 electrons. You'd have your second shell with the 1 electron. Okay, so 3 protons, 3 electrons, no charge. However, with lithium ion, okay, we're going to look at the valence shell here. Okay, now you have to ask yourself, is it easier to fill this valence shell or is it easier to empty it? And if you fill it, how many electrons are you going to need? You're going to need 7. And if you're going to empty it, you have to get rid of 1. So what do you think is easier for the atom to do? Get rid of 7 or get 7 or get rid of 1? Right, it's easier to get rid of 1. So in this case, lithium in the ion is going to have one less electron. Okay, and so that valence shell is empty. And we don't need to draw in an empty valence shell. That's just not necessary. Okay, so in this case we have 3 protons but only 2 electrons. And the difference between the two is 1. Okay? And because you have more protons than electrons, we're going to write a plus. So there's different ways to write the formula for lithium ion. Okay? You can write it as lithium 1 plus. The 1 is kind of redundant, so maybe you just write lithium plus. Okay? And others will write it as lithium plus 1. Okay? It doesn't matter, at least for your purposes. So either any of those ways is how you draw the ion for lithium. I now want to talk about the beryllium atom, okay, which is right next door to lithium. Okay, and this one's going to have, in an uncharged lithium atom, we're going to have 4 electrons. Okay, so we got the beryllium here. Sorry about the crookedness. And we got 2 electrons in the first shell, and then we got 2 more in the second shell. Okay, so 4 protons, 4 electrons for no charged. Okay. In the beryllium ion, though, okay, we're looking at the valence shell, and so we have 2 electrons in the valence shell. So what would be easier, to get rid of 2 or to get 6 to fill it? Right, it's easier to get rid of 2. So that's what beryllium's going to do. So we'll draw in beryllium with those 2 electrons. And the other 2 electrons are not there. Okay, so we still have 4 protons. But this time we only have 2 electrons. And the difference is going to be 2. And because you have more protons than electrons, you're going to have a positive charge. So if you want to write the formula for the beryllium ion, you could either write Be2 plus, or you can write Be plus 2. Doesn't really matter. If you look at the periodic table and go down 1 period below lithium and beryllium, you are going to have sodium and magnesium. Okay, so I want to start off with doing the electron arrangement of the uncharged sodium atom. So we're dealing with 11 protons, which means we're going to deal with 11 electrons in uncharged sodium. So we have your sodium atom, 2 electrons in the first shell. We have 8 electrons in the second shell. Okay. And then we have the last one on the valence shell. Okay. We have 11 protons, 11 electrons for no charge. But in the sodium ion, again, we look at the valence shell, and we see we have 1 valence electron. So we either have to empty it or fill it. So is it easier to get rid of 1 or get 7? It's easier to get rid of 1. So we're going to redraw here for our sodium ion. Okay. First 2 electrons in the first shell, and then 8 electrons in the second shell. Okay. We're still dealing with 11 protons, but this time we're only dealing with 10 electrons. Okay. So the difference is 1, and we have extra protons, so 1 plus. So you can write Na plus or Na1 plus. You can write Na plus 1, or you can just write Na plus. It doesn't really matter. Okay. And then we look to sodium's neighbor to the right, and we have magnesium. And in an uncharged magnesium atom, we're dealing with 12 electrons. So we got Mg nucleus. We got 2 electrons in the first shell. We got 8 electrons in the second shell. And then we got the last two in the valence shell. So 12 protons, 12 electrons, uncharged. The magnesium ion, again, you have 2 valence electrons. If you want to fill the shell, you need 6. If you want to empty the shell, you need to get rid of 2. It's easier to get rid of 2. And that's what we're going to do. Okay, so we'll have 12 protons and only 10 electrons, and the difference is 2, and since you have more protons than electrons, it's plus. So the formula for this is either Mg plus 2 or just Mg, or I'm sorry, Mg2 plus or Mg plus 2. So I wanted you to understand a pattern here. If you look at the periodic table, excuse the terrible drawing. If you noticed, we had lithium and we had sodium both had a +1 charge. We had magnesium and beryllium with a +2 charge. So instead of having to do this every single time you wanted to figure out the charge on an ion, we could kind of use the periodic table as a shortcut. And all the elements generally in group 1 have a charge of +1. In group 2, all of those elements are going to be +2 when they're charged as ions. Okay? We'll fill in the rest of this table in a little bit. What I want to do now is I want to go over to the other side of the periodic table. Okay? The first thing is that noble gases, group 18, if you draw out the electron arrangement of all those atoms, you find that the valence shell for all of those elements is full. And because it's full, it means that generally that the noble gases will not form ions. Okay? They will not form ions. So they'll be uncharged almost all times. What I do want to draw your attention to is oxygen and fluorine. So we'll start with fluorine. And if you determine the number of electrons in an uncharged atom of fluorine, it's 9 electrons. So you have your fluorine atom with your nucleus, 2 electrons in the first shell, and 7 electrons in the second shell. So we have 9 protons, 9 electrons, and the fluorine is uncharged. But if we want the fluorine ion, again, we have to either fill or empty the valence shell. If you want to fill it, we need 1 more electron. If you want to empty it, we got to get rid of 7. So what's easier? Just to get 1, and that's what fluorine does. Okay. So we're dealing with 9 protons still because it's fluorine, but this time we're dealing with 10 electrons. And the difference is 1, but this time it's negatively charged, okay, because you got more electrons than protons. So you can write this as F1 minus, you can write this as F minus 1, or you can just simply write it as F minus. Okay. We go to the left, we look at oxygen, and in the oxygen atom, we have 8 protons, which means we have 8 electrons. So we have the oxygen nucleus, 2 electrons in the middle, in the core, and then 6 electrons in the valence. So we have 8 protons, 8 electrons, and the difference is 0. In the oxygen ion, though, we're still going to have our 8 protons, but we're going to add 2 more electrons to the valence shell to fill it. And so we're going to have 8 protons, but this time we're going to have 10 electrons. And the difference is 2. And because you have more electrons than protons, the charge is minus. So the formula for the oxygen ion would either be O2 minus, or you can write O minus 2. It really doesn't matter. Chemists know what you're talking about. Okay? And the pattern repeats, okay? Just like it did with lithium and beryllium. If you go down one period and you're looking at chlorine and sulfur, you'd find that the ion for chlorine would also be negatively 1 charged. And for sulfur, it would have a negative 2 charge if it exists like an ion. Okay? So coming back up here to our periodic table, we could fill in the charges for the remaining groups. Now we started with group 1 is +1, group 2 is +2. We completely skip the transition metals. We don't care about them. Group 13, they're going to be +3 charged. Okay. It's a lot more complex than that, but for what you need to know, we're just going to say that the group 13 has a charge of +3. We said that fluorine and even chlorine will have a -1 charge when it's an ion. Oxygen and sulfur, when they exist as ions, will be -2. What do you think they're going to exist as in group 15? -3. Now you may be asking yourself, well, what about this group? What about group 14? The problem with group 14 is you have 4 valence electrons. So if you want to fill it, it's got to get 4. If you want to empty it, you have to get rid of 4. And that's a tall task for an atom to accomplish. So what you're normally not going to find in group 14 are ions. Okay? Carbon generally doesn't exist as an ion. As you've seen with covalent compounds, carbon prefers to share its electrons to fill its valence shell. Okay? And same thing with silicon, just below carbon in the group. And so this concludes the discussion on ions, and we're going to make compounds based upon the attraction of ions in the next video.